Okay, guys, so we're starting our next little unit. It's still a part of linear equations, but it's called systems. So we're starting first by just reviewing graphing linear equations that we learned last unit, and then we're going to kind of apply more as we go. So equations are often written in slope-intercept form, which we know is y equals mx plus b, where m represents the slope and b represents your y-intercept. So how did we graph when we had an equation when it was written in slope-intercept form? So first, you plot the y-intercept. And then use the slope to map out the next set of points or ordered pairs. Solutions to linear equations include any points located on the graphed line. Additionally, an ordered pair is a solution to an equation if when its values are substituted into the equation, it makes the equation true. So let's go ahead and we're going to graph 1, 2, and 3 on the graph given. So graph 1 is y equals 1/2 x. So I'm going to go ahead and plot on the origin. Slope tells me up 1 over 2. So I'm going to fill in the whole graph by going up 1 over 2, and then the opposite way. Connect your points, and then you're going to put an A somewhere next to your line to show that we just, sorry, the iPad went off. And there's Mr. Breck again. There we go. Okay. Next equation, y equals negative x plus 3. So plus 3, put plus 3 on the y-intercept. Slope is down 1, right 1, down 1, right 1, all the way till you fill in the graph on both sides. And don't forget to label it B. Last one is y equals negative 3. So negative 3, that means that this is going to be a horizontal with 0 slope, and label it C. So is 6, 3 a solution to the equation in A? How do we know? So all we have to do is just take the graph. So, or the equation, we could just do the equation. So I could do y equals 1/2 x. 6 would be your x, 3 would be your y. So just plug in these two values into this equation. So y is 3, 1/2 times x, which was 6. Half of 6 is 3. So since this is a true statement, your answer would be yes. The other way would be to plot it. So if I went over 6, up 3, is it on my graph? It absolutely is. So you have two ways to do it. But sometimes your graph will run short and you won't be able to see further ahead. So if you plug it into the equation, it makes it that much easier. So let's do the same with number 5. So number 5 is 10, 7. That's where I'm proving that point. We don't have 10 on this line, so if we just use the equation, y equals negative x plus 3, we can plug in the pieces. Sorry, the dogs are barking. So instead of y, we have negative 7. This is a negative here, so drop a negative down, and then plug in the x, which was 10. Negative 10 plus 3 is negative 7, so this is a true statement. So yes, it would be on the line. It says give a solution to the equation in C that you can see from the graph. So I just need to give any ordered pair that would lie on this black line here on my horizontal line. So I'm just going to pick this one right here just because that's what I decided. But I could have really picked any single one of these points. So since I'm picking this one, my ordered pair would be over negative 2, down negative 3. Give a solution to the equation in A that you cannot see on the graph. So again, A was y equals 1/2 x. So give me an x value that's not on the graph. So I'm going to just use 10. So if I were to plug in 10 for x, what would y be? It would be 5. So my ordered pair would be 10, 5 that I could choose that's not on this graph because it only goes up to 8. Charlotte is given the equation 3x minus 4y equals 12. She needs to create a graph of the equation but isn't sure how since she's only familiar with graphing from slope-intercept form. Devise a plan to help Charlotte graph the equation in the space below and then draw your graph line. So she's only familiar with slope-intercept form. So what could be another way that we could do this? We could do intercepts. So if I cover up my 3x, it says 3x equals 12. So that means x is 4. Or 4, 0. Cover up the 3x, and I'm left with negative 4y equals 12. So y equals negative 3, or 0, negative 3. And then I can draw my line. To double check myself, I could write it in slope-intercept form. So I would subtract the 3x. And divide everything by negative 4. So I'd be left with y equals positive 3/4 x minus 3. If I were to plot, I would plot the negative 3 first, and then go up 1, 2, 3, 1, 2, 3, 4. If I kept going, 1, 2, 3, 1, 2, 3, 4. So my line would have hit here if I kept going, or the opposite way, 1, 2, 3, 1, 2, 3, 4, and then I ran out. So you can see my line would have run into both of those either way. So you could have shown 2 different ways. Oh, excuse me. Oh, excuse me. So again, we're going to continue doing that. Okay, so let's do our x and y intercept. So I'm going to cover up. I have 3x equals 18. So x equals 6, or 6, 0. There he is again. All right. And then if I cover up my x, I have negative 9y equals 18. So y would be negative 2, or 0, negative 2. Crooked line, but you get the idea. So we're going to label that one, what, D? Number 10, cover up. 6x equals 9. If I divide by 6, I would have x equals 3/2, or 1.5. So right in the middle. If I do the opposite way, I'd have 3y equals 9. So y equals 3. Which would be E. And then the last one, 4x equals 8, or x equals 2. And then I have negative 2y equals 8, which y would equal negative 4. And that would be F. So which line above has a solution of 2, 0? 2, 0. So did any of these points give me 2, 0? They did. This one right here, which was line F. And if I wasn't sure, I could plug into the equation. So the F was 4x minus 2y equals 8. If I were to plug in a 2 for x and a 0 for y and solve, 4 times 2 is 8. 2 times 0 is nothing, so I'm left with 8 equaling 8, which is true. Which line above has a solution of 15.3? 15.3. How would you know? So I could either keep graphing, which will take me a long time on here because I don't have 15 on the line, or I plug into the equations. So I'm going to do 3 separate equations right now to check. So this is equation D, or line D. So I'm going to do 3 times 15 minus 9 times 3 equals 18. 3 times 15 is 45. Is 45 minus 27 18? Yes, it is. So I'm going to pick line D, and I don't need to go any further because I already got the answer. 14, list 2 solutions to line E, including one that cannot be seen on the graph. So E is the only one we haven't done. So again, let's pick the equation out. So for E, we had 6x plus 3y equals 9. I want to pick any point I don't see. So just pick an x that's not on here. So if I pick, where is E? E is this one, right? So if I were to pick, well, let's say -8. -8. Let's go -8, 0. See what happens. No. Hello. Sorry, I'm not looking at the right one. Erase. I'm sorry. I'm not looking at the right thing here. Okay, so I want to be able to find one hello that's actually on the line. So I'm going to look at my slope-intercept. So I'm going to rewrite this instead. It will be a little bit easier for us. Okay, because now I can multiply and kind of work this one backwards. So let's look if I'm on this line, right? We want to know which one would be off the line that we cannot see. So I need to plug in some numbers that could work here so that it will equal out to be the same thing. So if I wanted it to equal a y that's off of this map, so let's have a y of 8. I'm going to plug 8 in here, and I want to know what x will equal. I could have left it. Hold on, sorry guys. So I'm showing you 2 different ways we could have done this. Could have kept it in slope-intercept form or left it in standard form. So I'm just plugging in a y of 8 because I know that this would be my y-axis and it's running up. All right. So I can find out what my x value would be by doing that. So now I'll just solve for x. So if I'm doing this part first, I can subtract 3. 8 minus 3 is 5. If I divide by -2, my x will be -2.5. So if I were to plot this, -2.5 straight up to 8, it would hit the line. And it would work the same way if I left it in standard form. 6x plus 24 equals 9. If I subtract 24, 9 minus 24 would give me -15. -15 divided by 6 still gives me -2.5. So my ordered pair that could work for this would be -2.5, 8. And you could have picked any numbers to plug in, so you just had to pick one. You could have picked an x value and just plugged in for x to solve for y, or like I picked a y value, we solve for x. That's how I get my ordered pair, which this would be my final answer here. So on the back, you are working on 1 through 10. Okay, you are graphing and then answering the questions. This is due tomorrow, so please make sure that it gets done. Okay, have a good rest of your day.